Hello again, math students. Today is going to be our Pythagorean theorem review. I'm going to tell you right now, before I even get started, this is not going to be a short little video because I'm going to go over the entire review worksheet. So if there are parts of it that you feel totally confident and you don't need to watch this part, that's fine with me. This is really more of a reference for you. So if there's one section you're like, yeah, I'm not quite sure if I did that right, feel free to watch this just to get that explanation, but you don't necessarily have to watch the entire video. So this first problem is asking how you would use this illustration to prove the Pythagorean theorem. So we do have a right angle in here, but what I want you to remember here is that the side for A right here is 1, 2, 3, 4, 5 units long. But when I square that, I'm going to get 25. The side for B is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units long. And when I square that, when I make a square that is 12 by 12, that's 144. And for side C, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this is 13 units that I'm squaring. If I would count up all of those little squares, I would have 169 squares in this. So the way that I would show the Pythagorean theorem with this, so I would say, I'm not going to write this, it's written on the answer key, but the area of the square that's touching side A plus the area of the square that's touching side B is going to be equal to the area of the square that's touching side C. So that shows that A squared plus B squared does equal C squared. Usually we don't see this entire thing all drawn out with all the squares, but that's really what's happening. Remember that one video with the little Post-its that moved around with that awesome music? The 25 squares from square A plus the 144 squares from square B could all fit exactly into the 169 squares from square C. In these four problems, I just want to know if these side lengths would form a right triangle. So this is really the converse of the Pythagorean theorem. So in number 2, you have to be careful that you are using the longest side for C, right? So this is going to be 7 squared plus 24 squared. I want to know, is that equal to 25 squared? So 7 squared, everybody knows that one. That's going to be 49. 24 squared is 576. And 25 squared is 625. When I add these two together, I get 625, and it equals 625. So is this a right triangle? Yes, it is. Right? We want to show all the work. I want you to be writing all of this out. In number 3, again, the biggest side happens to be in the middle, not on purpose, but that's my C. So I'm going to have 9 squared plus 16 squared. Does that equal 20 squared? So 81 plus 256. I want to know, is that equal to 20 squared is 400. Now at this point, you should be able to look at this and say, this ends with a 1 and a 6. That's going to end with a 7 when I add. Clearly, it's not going to be equal to 400. This is 337, and that does not equal 400. So that is no. For number 4, we've got a triangle. It's not marked as a right triangle, so I don't know that it's a right triangle. So I would have to make sure that I'm using this as my C. So I would have 42 squared plus 6.5 squared, and I want to know, does that equal 45.3 squared? So 42 squared is 1764. Luckily, I had all this worked out ahead of time. And 6.5 squared is 42.25. I want to know, is that equal to 45.3 squared, which is 2052.09. Again, even just looking at the decimal places, on the left side, all I'm going to have is a 0.25, on the right side it's a 0.09. This is not going to work. When I add this, I'm going to get 1806.25, and that does not equal, oh, that's supposed to be 52. It's not the same, right? So clearly this is not going to be a right triangle. And number 5, it says this is a challenge problem just because we didn't do problems like this on this particular assignment. However, we have done problems with square roots, radicals in them. We know that the square root of 65 is going to be more than 8 because 8 squared is 64. So the square root of 65 is going to be a little bit more than 8, which means this is really the longest side in my triangle. So I would have 7 squared plus 4 squared as my A and B. I want to know, does that equal the square root of 65 squared? Well, that's 49 plus 16. And the square root of 65 squared, the square and the square root just cancel out. When I add 49 plus 16 together, I do get 65. So this one is yes. For numbers 6 and 7, this is where we had those application kind of problems. Be careful in number 6. The 44 has to be the C, right? That's the side that's across from the right angle. It's not touching the right angle. So we're going to say that this side that's missing is A. So I'll have A squared plus 35 squared equals 44 squared. And again, remember, this did give us a right angle. We know that this is a right triangle. We know that the Pythagorean theorem will work. So when I do this, 35 squared is 1225, and 44 squared is 1936. Now to solve this, I would have to get rid of this 1225. And that would be 711. And then we'll take the square root. And again, really we should be getting a positive and a negative answer, but the negative answer won't make sense in a triangle length. So we're only going to worry about the positive answer. 711 is not a perfect square, so we're going to have to round this. That's going to be 26.7, and this was all measured in feet. Again, make sure that if it's an A or a B that you're finding, it's got to be less than the hypotenuse, and this one is. For number 7, treasure map said to start at the old oak tree, walk 70 paces north and then 40 paces east. I've mentioned before, when we're using cardinal directions like this, we can assure that we're going to have right angles. So if we're going to start right here at the old oak tree, and we're going to go 70 paces north and then 40 paces east. I want to know the straight line distance from where I started. That just means find the hypotenuse, find the shortest way back to the oak tree. So I'm looking for my C. So I'll have 40 squared plus 70 squared equals C squared. 1600 plus 4900 equals C squared. And when I add those two, I get 6500. Now, if it was 6400, we'd have 80. But this is a little bit more than that. So we're going to get an answer that's a little bit more than 80. When I take the square root here, I'm going to get that this is about, paces is my label here. So 80.6 paces, just over 80. If we have this building, and apparently it's a burning building. We don't see that in the picture, but that's okay. The window is 40 feet above the ground, and the base of the ladder is placed 9 feet from the base of the building. I want to know how long that ladder has to be. right? You can't have the ladder right smack up against the building or it's going to fall over. And you need to make sure that this is a safe distance, but we also have to make sure that the ladder is going to actually be long enough. So again, we are looking for the C in this case. So we know that I'll have 9 squared plus 40 squared equals C squared. 81 plus 1600 is what I get there. So 1681 equals C squared. And then we'll take the square root of both of those. And this actually happens to be a nice, perfect square. Not that you would recognize it necessarily from that, but this works out to be 41 feet for the length of the ladder to be able to reach that. If I have 2 points, I should be able to find the distance between them. So if I've got the point 5, 2, that would be right here, and -3, -1. Remember, for every ordered pair, we go left and right first, and then up and down second. So those are my 2 points. To find the distance between them, I'm going to have to draw in a right triangle. Remember, this is going to be the hypotenuse. I'm going to do my best job to get a straight-ish line there. So I would need to construct or draw the right triangle so that I know for sure how long the legs are. This side is 3 units long, and we've got 1, 2, 3, 4, 5, 6, 7, 8 units here. So now that I've got those 2 measurements, I can use that to find the distance between those 2 points, which will be the hypotenuse. 3 squared plus 8 squared equals C squared. 9 plus 64 is going to be 73. And we'll take the square root. This is approximately 8.5 units. To be able to find a diagonal through a 3D shape, and remember we've talked about how sometimes when we have a 3D shape represented on a flat paper or on my screen, sometimes it's hard to visualize this. I do have the right angles marked in here, so that does help a bit. So before I can get to the diagonal for X, I need to be looking at the right triangle that's formed from these 2 sides, and it does even say here that I've got a right angle, even though perspective makes it look like it's not really a right angle. And I want to find this length, which will be C, in that right triangle. Now, 5 and 12, that's part of a Pythagorean triple, which you may remember. But if I have 5 squared plus 12 squared, this is actually right from the very first problem that we did. 25 plus 144, which is 169, equals C squared. And square root on both sides gives me that C is going to be 13. So this is 13 units long. Now, when I look at the triangle that uses this 13 that we just found with the height of this rectangular prism, which is 5, that will help me find X. So, and again, they show that this is a right angle right here. So I've got 13 squared plus 5 squared will be, and I'm going to label this as X squared. So I've got 169 plus 25, which would give me 194. Oh, and I went right back to a C right there, equals X squared. And we'll go square root, square root. So X is going to be about 13.9. This was all measured in millimeters. So that's the length of that longest diagonal in that rectangular prism, right? So this is really our final answer. Okay, we did take a day this week on finding missing lengths in these triangles. So when I have that blue line drawn, I didn't say this specifically in the video, but that is the altitude of the triangle. The whole big triangle, not a right triangle. However, when I draw that altitude, that height, it does give me a right angle, which gives me two right triangles that are part of this. Now, when I look for in the left triangle, this side A, again, I'm sure that some of you know what this answer is going to be. I'll have A squared plus 4 squared. We have to make sure that we've got that 5 as the hypotenuse. So A squared plus 16 equals 25. So A squared equals 9. And then the square root, I'm going to get that A is 3. It doesn't necessarily look entirely accurate in terms of the lengths, but I guess it's not too far off. Now that we've got that, we also want to find the side on the right, and that is going to be the hypotenuse in that triangle. So we're going to find this C over here. So the 4 and the 2 are my legs. So 4 squared plus 2 squared equals C squared. 16 plus 4 gives me 20 for C squared, and then we'll do the square root on both sides. This one does have to get rounded. That's about 4.5. Okay. We'll have one more of those. Same kind of situation. Actually, the setup looks very similar. It's just that this time we won't have any of those nice Pythagorean triples to work with. So let's find this A. A squared plus 7 squared equals 12 squared. Oh, that was like a 9 there. So A squared plus 49 equals 144. And when we get rid of the 49, we'll be left with A squared equals 95. I'm going to take the square root of that. It'll be a little bit less than 10, right? Because if that was 100, the square root would be 10. So this is going to be 9.7. And then to find the right side, which again is going to be a hypotenuse in this one, I've got 3 and 7 for my legs. So 9 plus 49, which is going to be 58, and square roots. That's about 7.6. And again, when I did this lesson originally, I said that the reason that we would want to do this sometimes is if we wanted to find the area of this triangle, we would need to know the base. We would need to know what that side A was at least, so that we could multiply that by the height, or the 7, and then divide by 2. But we just weren't going that extra step for now. In this problem, if I have a rectangle, you know to find the area of a rectangle, I need the length times the width, or the base times the height. Well, I don't know either one of those. So I would have to use the Pythagorean theorem and write triangles to get the lengths of each of the sides. So if I wanted to find, for instance, this long side, which will match the one on the bottom, that long side, I would have to draw in my legs of the right triangle to make sure that this is the hypotenuse that I was looking for. This is 1, 2, 3, 4, 5, 6 units long, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units long. So I'm going to use those two dimensions to find, I guess we're just going to stick with that as a C. So we'll find 6 squared plus 12 squared equals C squared. 36 plus 144, and that is 180. And we would take the square root on both sides. 180 is not a perfect square, so this is going to be about 13.4. After I know that, I need to find the shorter side of the rectangle. So if I would draw in my right triangle here using the hypotenuse as the side of the rectangle, this is 2, this is 1, 2, 3, 4. So 2 and 4 are my legs, which we've already done. So that's going to be 4 plus 16, so that's 20, and then the square root, which should be about 4.5. Now, that's all great, but we're not done, right? What I really need here is the area of the rectangle. And the area of the rectangle is going to be the base times the height, or the length times the width. So I would need to take that 13.4 and multiply it by the 4.5. When I multiply those, I get 60.3. Remember, each of these was in units, but area will be square units. Because when I multiply the 13.4 times the 4.5, you'd think that there'd be 2 decimal places, but the 4 times the 5 is a 20. So the last digit is actually just a 0. This one didn't need to be rounded. If it says specifically to round to the nearest 10th, you would have to make sure that you're actually rounding your final answer as well. And our last problem is another 3D problem. Whoop, skipped a slide. There we go. 3D problem, a little bit blurry on this picture. But the trickier part of this one is that I didn't draw in one of the segments that we need. I'm going to need to find the length of that segment so I can be looking at this right triangle. And again, by perspective, this does not look like the right angle. I would think probably the one in the back looks more like a right angle. But because I know that this is a rectangle and a rectangular prism, that base being a rectangle, that has to be a right angle. The long side in front is 10. This side, even though it's marked on the other side, I know that that is 3. So the 10 and the 3 are my legs, right? So I would have 10 squared plus 3 squared equals c squared. So I'll have 109 equals c squared. So you have 2 options here. You can either leave this as the square root of 109, which is my preference. I really like it that way because it makes my next step easier. Or because everything else that we've done, we say round to the nearest 10th, that would be about 10.4. Okay, so you can use either one, it doesn't matter. And on my answer key, I did this with both of those answers and we get the same answer either way. Now that we have that, I need to use that length that I just found with the height of the rectangular prism, which is 6, to find the diagonal all the way through. So that's like the back left corner to the front right corner. So if I go with the decimals, which is what we're tending to do, 6 squared plus 10.4 squared gives me c squared. So this is 36. 10.4 squared is 108.16. So when I add those, I'm going to get 144.16. Now, the square root of 144 is 12. This is so close to 144 that when you take the square root and round it, it's still going to round to be 12 or 12.0. I prefer to have that decimal there so that we can see that we actually did round to get that answer. If you had done this one with the square root of 109, we would have 6 squared plus the square root of 109 squared equals c squared. 36 plus 109. Notice the difference. I had 108.16 versus 109. Very similar or very close answers there. When I add those two together, I'm going to get 145. And the square root of that also rounds to be 12.0. Okay, now that was the entire review done for you. Hopefully you were okay with all those problems that we did, but if you need to look over the key again or rewatch any part of the video, feel free to do that. If you're still not sure about something, check with me. If you need help, please talk to me before the test. Don't wait until after the test and say, oh yeah, I never really understood that part. Make sure that you ask if you need any help, and good luck on the test.